In this course, we have discussed two types of firms: firms that are price takers and firms that are price setters. Price-setting firms have what we call market power. So in this section, we're going to discuss what market power actually means. So we're going to analyze this idea of market power within our profit framework. So we know that firms are always attempting to maximize profits, but how does this change when we have a price-setting firm? So market power, by definition, is the ability to set price above marginal cost. Price-taking firms don't have this ability. So let's take a look at a graph. So what we have graphed here is marginal revenue and marginal cost. And if you are a price-setting firm, at what quantity will you want to produce? Well, let's look at the intersection point of those two curves. If we go to the left of that intersection point, we see that marginal revenue is above marginal cost. So in that case, profits will be made. But if you go to the right of that point, marginal cost is greater than marginal revenue. So just by analyzing this graph, it makes sense to think that the profit maximizing point is likely at that point of intersection. So when a firm can set the price, we're going to calculate profit a different way than we calculated it when we had price-taking firms. So it's slightly different. It's not entirely different. We're still going to rely on marginal cost. So we're going to rely on our laptop example in this section. So we have the laptops that are cool and unique, and they're sold at our own stores. And we're going to produce each unit until marginal cost equals marginal revenue. If we produce beyond that, it's not worth it. And that's exactly what we saw in that graph on the previous slide. So that becomes our profit maximizing condition. Marginal cost equals marginal revenue. And we can think of marginal revenue as actually the marginal benefit of selling that unit. So to calculate actually the point of profit maximization, we can use calculus. So recall that our profit equation is profit equals revenue minus cost. And remember, when we're maximizing, we're going to take the derivative of profit and then set it equal to 0 and solve for Q. So the derivative of profit is going to be equal to the derivative of revenue with respect to Q minus the derivative of cost with respect to Q. But we know that the derivative of revenue with respect to Q is just marginal revenue, and likewise for cost, it's just marginal cost. So what we end up doing when we set this derivative equal to 0 is we're setting marginal cost equal to marginal revenue. So there our profit maximization condition pops out of the calculus. So let's take a look at an example. We have a demand of 1,000 minus 5Q. And let's say our cost function is 500 plus 200Q. So let's calculate what the profit will be. So I'm going to write that as a pi. So recall that profit is simply revenue minus cost. And subbing in what we know, so our demand equation times our Q minus our cost equation. Simplifying this down just a little bit, I'm going to get 1,000 Q minus 5Q squared minus 500 minus 200 Q. So now if we take the derivative of our profit with respect to Q, this represents our revenue, and this is our cost. So if we take the derivative, we're going to get marginal revenue minus marginal cost. So let's take that derivative. We're going to get 1,000 minus 10Q minus 200. And then setting that equal to 0 and solving, that tells me that the profit maximizing quantity is 80. Now I can go back and solve for the price that's associated with that quantity by just going back to the demand curve. So I'm going to figure out what price is when quantity is 80. So that's going to be 1,000 minus 5 times 80. And this gives us 600. So now with both my price and my quantity, I can solve for what profit actually is. So this is going to be my price times quantity minus the cost at that quantity. And this works out to be 31,500. So let's look at this graphically. So here we have our familiar downward sloping demand curve, P of Q, and our marginal revenue curve, noticing that it intersects at the same y-intercept and it has double the slope. So let's throw on our marginal cost line. So this is horizontal because our marginal cost is constant in this case. So recalling that our profit maximization condition is where marginal cost equals marginal revenue, we're going to look at that intersection point of those two curves and follow it down to the x-axis. And that will tell us where our quantity that we want to produce at is. And then following this quantity up to the demand curve gives us what the price is for this quantity.